Welcome to the Deep Dive. Today we're taking a serious plunge into the incredible, sprawling story of India.
Yeah, it's quite a topic.
We've got a whole stack of material here covering its massive geography, jaw-dropping physical landscapes, the rivers that are its lifelines.
The famous monsoon climate, and even the vital picture of its population. It's a lot to cover.
It really is. It feels like trying to understand an entire continent packed into one country.
Absolutely. And our goal isn't just to list facts, but to really unpack these sources, the articles, the research, the notes we've gathered.
Right, to pull out the most important insights for you, the listener.
Exactly. Think of it as getting a genuine shortcut to being well-informed about this place, maybe with a few surprises along the way. We're just going to guide you through what truly matters from this material.
Okay, let's dive right in then. Where? Where do we start? How about just placing India? How big is it, and where exactly does it sit on the planet?
Well, first off, location-wise, it lies entirely in the Northern Hemisphere. That's key.
Northern Hemisphere.
Got it.
And size.
Size-wise, it's huge. We're talking 3.28 million square kilometers of land.
3.28 million. That's a big number. How does that stack up globally?
It puts India as the 7th largest country in the world. By land area.
7th largest.
Yeah.
Wow. Okay, and just to place it on the map, there's that significant line, isn't there, that cuts through it?
Absolutely. The Tropic of Cancer, that's 23.5 degrees north latitude, slices the country into almost two equal halves.
Right, so partly tropical, partly subtropical, roughly speaking.
Exactly. And you've got the mainland, of course, but don't forget the islands.
Oh, yeah, the Andaman and Nicobar Islands way out in the Bay of Bengal.
And the Lakshadweep Islands over in the Arabian Sea, they're part of the picture, too.
Right, the island territories. Now, what about its borders? It must have a massive perimeter being that size.
It does. The land boundary alone is vast, roughly 15,200 kilometers.
15,000, okay. And the coast.
And its coastline, including those islands we just mentioned, stretches over 7,500 kilometers.
That's a lot of coast. What about the physical edges? What kind of terrain defines where India stops, so to speak?
Good question. To the northwest, north, and northeast, it's bounded by these relatively young fold mountains, the Himalayas, big rugged ranges.
The Himalayas, okay. But then it changes shape further south.
It does. If you look south of about 22 degrees north latitude, the land starts to dramatically narrow. It tapers down, extending into the Indian Ocean.
And that shape is key to how the ocean is divided around it, right? That tapering peninsula.
Precisely. That tapering landmass effectively splits the Indian Ocean. You get the Arabian Sea on the west coast and the Bay of Bengal on the east coast.
Okay, here's where it gets really interesting to me, based on the sources. This huge north-south and east-west spread. It spans quite a few degrees of longitude.
It does, about 30 degrees of longitude east to west, and similarly north to south.
So you'd think that would create a massive time difference across the country.
It absolutely does. Even though the east-west extent might feel a bit smaller than the north-south when you look at a map, that 30 degrees of longitude is significant.
How significant?
It naturally creates a time lag of 2 hours between the very western edge, say Gujarat, and the eastern edge, like Arunachal Pradesh. The sun literally rises 2 hours earlier in the east.
2 hours. So how do they handle that without total chaos? Must be tricky for schedules.
Yeah, imagine. The practical solution is they've adopted a single standard meridian for the whole country.
A standard time zone, basically.
Exactly. That line is at 82 degrees, 30 minutes east longitude, and it passes near a place called Mirzapur. The local time there sets the standard time for everyone across India, keeps things synchronized.
The central clock that keeps the trains running.
Yeah.
Theoretically on time.
Theoretically, yes.
And just quickly, that north-south latitudinal spread you mentioned, that also affects something we all experience daily, doesn't it? Like daylight hours.
Yes, absolutely. It influences the duration of day and night. If you're way down south, closer to the equator, the length of day and night doesn't change much throughout the year.
Pretty steady, 12 and 12, almost.
Almost. But as you move further north, that difference becomes much more pronounced, especially between summer and winter. Longer days in summer, shorter in winter. You know the drill.
Right. Okay, let's talk about India's location strategically. Being this huge landmass pushing down into the Indian Ocean right between East and West Asia, that must be a massive advantage.
It is, strategically and economically. It puts India smack in the middle of the trans-Indian Ocean trade routes. These routes connect Europe and West Asia with East Asia.
So it's a natural hub.
Pretty much. And the fact that the Deccan Peninsula sticks out so far into the ocean allows India to have close historical and Modern contact with all the surrounding regions, West Asia, Africa, Europe from the west coast, Southeast and East Asia from the east coast.
And the sources really emphasize that unique position, don't they? Something about the coastline.
They do. A key point highlighted is that no other country has such a long coastline right there on the Indian Ocean like India does.
Really? No other country.
Not with that kind of protrusion and length directly on the main body of the ocean. And that eminent position is cited as the main reason the ocean itself is named after the country.
The Indian Ocean. That's a powerful connection. Wow.
It is pretty unique when you think about it.
Thinking historically, what impact did something like the opening of the Suez Canal have on this location?
Oh, a huge impact, a game changer, really. When the Suez Canal opened back in 1869, it dramatically reduced India's distance from Europe.
By how much?
By about 7,000 kilometers. Suddenly, those maritime connections became much faster, much more dominant than they had been previously.
So before the Suez Canal, were land routes more important for connection?
Very much so. The sources point out that the land routes through the mountain passes in the north were actually used for contact much earlier than the sea routes.
Ancient trade routes.
Exactly. This is how ideas and goods traveled back and forth for centuries. Things we now take for granted, like Indian numerals and the decimal system, they spread to other parts of the world via these land paths.
And influences came in the other way too.
Yes, influences like Greek sculpture, architectural styles like domes and minarets from West Asia came into India through these same routes. It was a two-way street.
So centuries of exchange via those mountain passes. Fascinating. Okay, finally, just to complete the picture from the sources, who are India's closest neighbors?
Right, the neighbors. On land, you're looking at Pakistan and Afghanistan in the northwest, then China, Nepal, and Bhutan to the north, and Myanmar and Bangladesh to the east.
That's a lot of shared borders.
It is. And then across the narrow seas to the south, you have the island nations of Sri Lanka, separated by the Palk Strait, and the Maldives further southwest.
And the sources briefly touched on internal divisions from a historical perspective. Just a quick note on that.
Yeah, just noting that before independence in 1947, there was a distinction between areas ruled directly by the British, the provinces, and the many princely states, which were ruled by local hereditary rulers, but under overall British authority.
Right, a complex system back then.
Very complex. Today, of course, it's divided into states and union territories, the modern administrative structure.
Okay, brilliant. We've pinned India on the map, got a sense of its scale and neighbors. Now let's dig into the sheer variety of the land itself. The sources say India has practically every major physical feature imaginable.
It's true. It's quite remarkable. You've got towering mountains, huge fertile plains, ancient plateaus, arid deserts, long coastal strips, and islands. It's like a geological textbook all in one country.
A geological goldmine of features, as you said. And these features, they tell a story, don't they? About the land's deep past.
Absolutely. For instance, the Peninsular Plateau in the south, that's part of Gondwanaland, one of the oldest and most stable land blocks on Earth, formed from ancient crystalline, igneous, and metamorphic rocks.
Ancient and stable. Contrast that with
the Himalayas and the vast northern plains. These are much, much younger in geological terms. They are considered recent landforms, and the Himalayas especially form an unstable, still rising, with very youthful topography, sharp peaks, deep valleys.
Wow, so old stable bits and young active bits all together.
Exactly. And the sources break this incredible variety down into 6 major physiographic divisions or areas.
Okay, let's get a feel for each of them. What are the big 6?
The big 6 are the Himalayan mountains up north, the northern plains just south of them, the Peninsular Plateau further south, the Indian Desert out west, the coastal plains flanking the plateau, and finally the islands.
Got it. Starting up north then with the most dramatic, the Himalayas.
Right. These are, as we said, young, structurally fold mountains. They form this massive arc along the northern border, stretching west to east from the Indus River to the Brahmaputra River, about 2,400 kilometers.
A huge barrier. And they vary in width.
They do. They're wider in the west, maybe 400 kilometers in Kashmir, and narrow down to about 150 kilometers in the east, in Arunachal Pradesh.
And they're not just one single ridge, are they? The sources mention parallel ranges.
Correct. There are 3 main parallel ranges. The northernmost one is the Great Himalayas, also called the Himadri. This is the highest, most continuous range with the loftiest peaks averaging over 6,000 meters. Think Mount Everest, Kanchenjunga. Though Everest is in Nepal, the core is made of granite. It's permanently snowbound, lots of glaciers.
Kanchenjunga is in India, though, right? A major peak.
Yes, Kanchenjunga is India's highest peak within the Himalayas. South of the Himadri is the next range, the Himachal or Lesser Himalaya.
Lesser Himalaya, what's that like?
It's still quite rugged, with altitudes generally between 3,700 and 4,500 meters. This is where you find those famous valleys known for hill stations, the Kashmir Valley, Kangra, Kulu Valley, popular tourist spots.
The hill stations. And the outermost range.
That's the Shiwaliks. These are much lower, altitude between 900 and 1,100 meters and only 10 to 50 kilometers wide. They're composed of unconsolidated sediments brought down by the rivers from the main Himalayan ranges.
Unconsolidated, so looser material.
Exactly. And between the Lesser Himalayas and the Shiwaliks, you find these interesting longitudinal valleys.
Oh yeah, you mentioned those, the Duns.
Yes, the Duns. Dehra Dun is the most well-known example, but there are others like Katli Dun and Patli Dun. These are relatively flat valleys nestled between the ranges.
And the Himalayas don't just stop, they curve around in the east.
That's right. Beyond the Dihang Gorge, where the Brahmaputra cuts through, the Himalayas bend sharply south and run along India's eastern boundary. This part is called the Purvachal, or the Eastern Hills.
What are they like there?
They're mostly composed of strong sandstones covered in dense forests. They include hills you might have heard of, like the Patkai Hills, the Naga Hills, Manipur Hills, and the Mizo Hills.
Okay, that covers the mountains. From those rugged heights, we drop down to the vast flatlands just south of them.
The Northern Plain. This is an immense stretch of flatland. It was formed by the interplay of three major river systems, the Indus, the Ganga, and the Brahmaputra and their tributaries.
Formed by rivers. So deposition.
Exactly. Over millions of years, these rivers deposited vast amounts of fertile alluvial soil, creating this huge plain. It covers an area of about 7 lakhs square kilometers, which is 700,000 square kilometers.
And that fertility makes it incredibly important, right?
Hugely important. It's about 2,400 kilometers long and between 240 to 320 kilometers broad. Because it has that fertile soil, plentiful water supply from the rivers, and a favorable climate, it's extremely productive agriculturally.
The breadbasket of India, in many ways.
You could say that, and consequently, it's one of the most densely populated regions on the planet. People settled where they could farm.
The sources also mention the plains aren't just uniformly flat, that there are subtle variations in relief. Can you break those down?
Sure. It's not perfectly billiard table flat everywhere. Right at the foot of the Shiwaliks, there's a narrow belt, about 8 to 16 kilometers wide, called the Habar.
Habar. What's that like?
It's made up of pebbles deposited by the streams coming down from the mountains. Interestingly, the streams often disappear underground in this porous belt.
They just vanish.
Seems like it. But they reemerged south of the Habar in a zone called the Terai.
Okay, the Terai.
This is a wet, swampy, marshy region. It used to be thickly forested and full of wildlife, but much of it has been cleared for agriculture and settlement over time, especially after partition.
Right. And beyond the Terai.
You get the main part of the plain, which is made of older alluvium. This is called the Bangar. It lies above the floodplains of the rivers and looks a bit like a terrace. It contains these calcareous deposits, locally known as Kankar.
Conquer nodules.
Okay.
The stuff right by the rivers.
That's the Kadar. These are the newer, younger deposits found in the floodplains themselves. The soil here is renewed almost every year by floods, making it very fertile and ideal for intensive agriculture.
Bangar is old alluvium, Kadar is new. Got it. Okay, moving south again from the plains, we hit that ancient heartland you mentioned earlier.
The Peninsular Plateau. This is a large tableland composed of those old, crystalline, igneous, and metamorphic rocks we talked about, part of the ancient Gondwana landmass.
And it looks different from the Himalayas.
Very different. Instead of sharp peaks, it's characterized by broad, shallow valleys and rounded hills. It shows its age, geologically speaking.
It's split into two main sections, right?
Yes, broadly speaking. The part lying north of the Narmada River is generally known as the Central Highlands.
Central Highlands. What areas does that cover?
It covers a major part of the Malwa Plateau. It's bounded by the Vindhya Range to the south and the old eroded Aravalli Hills to the northwest. The rivers here, like the Chambal, the Sindh, the Betwa, and the Ken, flow from southwest to northeast, which actually shows you the slope of this part of the plateau.
Interesting. And the other part?
The other major part is the Deccan Plateau, which is a large triangular landmass lying south of the Narmada River.
The Deccan. That's a famous name.
It is. It's bordered by the Satpura Range in the north, and other ranges like the Mahadev, Kaimur, and Maikal Hills extend eastward. The Deccan Plateau is generally higher in the west and slopes gently eastwards.
And the edges of this whole plateau are marked by those famous ghats.
Exactly. Along the western edge, running parallel to the coast, are the Western Ghats, and along the eastern edge are the Eastern Ghats.
How do they compare?
They're quite different. The Western Ghats are higher, more continuous. You can only cross them through passes like the Thal, Bor, and Pal Ghats. Their average elevation is around 900 to 1600 meters, and they generally increase in height from north to south.
Higher in the south. Any famous peaks?
Yes, the highest peaks like Anaimudi and Dota Betta are located in the southern part of the Western Ghats. They also cause orographic rain, forcing the moist monsoon winds upwards, leading to heavy rainfall on their western slopes.
Makes sense. And the Eastern Ghats?
The Eastern Ghats are lower, averaging only about 600 meters. They stretch from the Mahanadi Valley down to the Nilgiris in the south, where they meet the Western Ghats. But unlike the Western Ghats, they are discontinuous and irregular, dissected by the large rivers flowing from the plateau into the Bay of Bengal.
So broken up by rivers like the Mahanadi, Godavari.
Exactly. Krishna, Kaveri, they've all carved valleys through the Eastern Ghats. The highest peak here is Mahendragiri, but it's significantly lower than the peaks in the Western Ghats. You do find some hills here too, like the Chevroy Hills and Javadi Hills.
And some famous hill stations are actually in the Ghats region.
Yes, famous hill stations like Udi, Udagamandalam, and Kodaikanal are located in these southern hill ranges, technically where the Ghats meet, or in associated ranges like the Nilgiris and Palani Hills.
Okay. The plateau is also famous for a specific type of soil, isn't it?
Yes, a very distinct feature, especially of the Deccan Plateau, is the black soil area known as the Deccan Trap.
Deccan Trap. Volcanic origin.
Exactly. This area was formed by intense volcanic activity millions of years ago. The resulting igneous rocks have weathered over time to form this black soil, which is very good for growing cotton, for example.
And just quickly, the Aravalli Hills you mentioned,
Yeah.
bordering the Central Highlands.
Right. They lie on the western and northwestern margins of the peninsular plateau. They are very old, fold mountains, much older than the Himalayas, and now they're highly eroded, appearing as broken hills. They stretch from Gujarat up towards Delhi in a southwest-northeast direction.
Very ancient hills. Okay, from the plateau, let's quickly hit the drier parts of the country.
That would be the Indian Desert, also known as the Thar Desert. It lies to the west of the Aravalli Hills.
What's it like? Sand dunes?
Yes, it's an undulating, sandy plain covered with sand dunes. You get different types, like crescent-shaped dunes called barshans, which are quite common. It receives very low rainfall, less than 150 millimeters per year, so it has an arid climate and sparse vegetation cover.
Not much water then. Any rivers?
Streams appear mainly during the rainy season, but soon disappear into the sand as they don't have enough water to reach the sea. The Luni is the only large river in this region, and even that's seasonal and often doesn't reach the sea.
Makes sense for a desert. Okay, flanking the big peninsular plateau are the coastal plains.
Right. These are narrow strips of plain land running along the edge of the plateau, between the Ghats and the sea.
Are the western and eastern ones different?
They are. The western coastal plain, between the Western Ghats and the Arabian Sea, is relatively narrow. It's divided into sections. The Konkan coast in the north, Mumbai-Goa area, the Kanad Plain in the central part, and the Malabar coast in the south.
Konkan, Kanad, Malabar,
Okay.
and the east.
The eastern coastal plain, along the Bay of Bengal, is generally wider and more level. Its northern part is called the Northern Sircar, and the southern part is the Coromandel coast.
And this is where the big rivers reach the sea.
Exactly. The large rivers like the Mahanadi, Godavari, Krishna, and Kaveri have formed extensive fertile deltas along this coast. Lake Chilika, India's largest saltwater lake, is also an important feature on the eastern coast in Odisha.
Right, Chilika Lake. Okay, finally, the sixth region, those islands we mentioned right at the start.
Yes, the two main groups. First, the Lakshadweep Islands, lying close to the Malabar coast in the Arabian Sea.
What are they like?
These are small islands composed of coral. They're formed from the skeletons of tiny marine organisms called coral polyps. The total area is very small, only about 32 square kilometers. Kavarati Island is the administrative headquarters. They have a rich diversity of flora and fauna, and one island, Piti, is a bird sanctuary.
Coral Islands. And the other group?
The Andaman and Nicobar Islands. These lie further away in the Bay of Bengal. They form a longer, elongated chain running north-south. The northern part is the Andaman group, the southern is the Nicobar group.
And these aren't coral islands?
No, they are believed to be an elevated portion of submarine mountains, basically the peaks of an underwater mountain range sticking out of the sea. They are bigger and more numerous than Lakshadweep.
Strategically important too, I imagine.
Very much so. They also boast a great diversity of plants and animals. Because they lie close to the equator, they experience an equatorial climate and have thick forest cover. India's only active volcano, Barren Island, is also located here.
An active volcano. Wow. Okay, so we've covered the 6 major physical divisions. What does this incredible variety tell us about India as a whole? What's the takeaway?
Well, the sources really emphasize this diversity isn't just about interesting scenery, it translates directly into a huge variation in resources and potential.
How so?
The mountains are a major source of water and forest wealth. The northern plains, as we said, are the granaries of the country, vital for agriculture. The plateau is a storehouse of minerals crucial for industry, and the coastal regions and island groups provide sites for fishing and port activities.
So each region contributes something different.
Exactly. This immense physical diversity provides the foundation for the country's resource base and offers tremendous possibilities for development, but also presents unique challenges in different regions.
That's a perfect transition, from the land itself to the water that shapes it and flows through it. Let's talk about India's drainage systems, the rivers. They seem fundamental.
They truly are. The term drainage basically describes the river system of an area. And a drainage basin, or river basin, is simply all the land that is drained by a single river system, including all its tributaries.
Okay. And you mentioned water divides earlier.
Right. A water divide is just an elevated area, like a mountain or an upland region, that separates 2 different drainage basins. A raindrop falling on one side will flow into one river system, and a drop on the other side will flow into another. We mentioned Ambala earlier, sitting on the divide between the Indus and Ganga systems.
Got it. In India's rivers, the sources put them into 2 major groups based on their origin.
Exactly. You have the Himalayan rivers and the peninsular rivers, and they are quite different beasts, really.
Different beasts. How so? What are the key differences?
Well, the Himalayan rivers are mostly perennial.
Perennial meaning?
Meaning they have water throughout the year. This is because they are fed not just by rainfall, but also by meltwater from the snowfields and glaciers high up in the Himalayas.
Snowmelt, too. Makes sense.
Also, major Himalayan rivers like the Indus and the Brahmaputra actually originated north of the main mountain ranges and have cut deep gorges through them to reach the plains. They have very long courses from their source to the sea.
Long journeys. What else characterizes them?
They perform intensive erosion, especially in their upper courses, carrying huge loads of silt and sand. In their middle and lower courses across the plains, they form features like meanders, oxbow lakes, and eventually very large, well-developed deltas at their mouths.
Okay, so perennial, long, erosive, carrying lots of silt, forming deltas. What about the peninsular rivers then? How do they contrast?
Okay, they're largely seasonal. Their flow is dependent almost entirely on rainfall. So during the dry season, even the larger peninsula rivers have reduced flow, and smaller ones might dry up altogether.
No snowmelt to keep them going.
Exactly. Their courses are generally shorter and shallower compared to the Himalayan rivers. Most of them originate in the Western Ghats, which acts as the main water divide in peninsular India.
And most flow east.
Yes, the majority flow eastwards and drain into the Bay of Bengal, forming deltas at their mouths, similar to the Ganga and Brahmaputra, though usually smaller.
But you mentioned earlier, not all peninsular rivers flow east, right? There are exceptions.
That's a key difference within the peninsular group. There are a couple of major rivers, the Narmada and the Tapi, that actually flow westwards.
West into the Arabian Sea?
Correct. And interestingly, instead of forming deltas like the east-flowing rivers, these west-flowing rivers form estuaries at their mouths.
Estuaries, not deltas. What's the difference there, briefly?
A delta is where a river drops its sediment load as it enters the sea, creating new land, often triangular-shaped. An estuary is more like a funnel-shaped tidal mouth of the river, where the river current meets the sea tide, and the sediment tends to be washed out rather than deposited.
Okay, interesting distinction. Let's look at a couple of the biggest Himalayan systems mentioned in the sources. The Indus, for instance.
Yeah.
Where does that start?
The Indus rises in Tibet near Lake Mansarovar. It flows westwards, entering India in the Ladakh region, where it carves out a spectacular gorge. Several tributaries like the Zaskar, Nubra, Shok, and Hunza join it in the Kashmir region.
And its main tributaries, the famous 5 rivers of Punjab.
Right. The Satluj, Beas, Ravi, Chenab, and Jhelum, they all join together first and then enter the Indus near Mithankot in Pakistan. The Indus then flows southwards through Pakistan to eventually reach the Arabian Sea near Karachi.
So a lot of its course is actually outside India?
Yes, it's one of the world's longest rivers, about 2,900 kilometers, but only a little over a third of its drainage basin lies within India, mostly in Jammu and Kashmir, Ladakh, Himachal Pradesh, and Punjab. There's actually an Indus Water Treaty between India and Pakistan that governs how the water is shared.
Ah, okay. Now, the other giant, the Ganga, or Ganges.
The Ganga. Its headwaters, called the Bhagirathi, emerge from the Gangotri Glacier in the Himalayas. It's joined by another river, the Alaknanda, at Devaprayag in Uttarakhand. From that confluence onwards, it's known as the Ganga.
And then it flows down to the plains.
Yes. It emerges from the mountains onto the plains at Haridwar. Then it flows eastwards across the vast northern plain. It's joined by many tributaries along the way.
From the Himalayas and from the south.
Both. Major tributaries joining from the Himalayas include the Yamuna, which rises from the Yamunotri Glacier and flows parallel to the Ganga for a while before joining it at Allahabad, now Prayagraj, the Gaghara, the Gandak, and the Kosi. Tributaries joining from the peninsular uplands to the south include the Chambal, Betwa, and Son.
And it forms that famous delta at the end.
Yes. It flows eastwards till Farakka in West Bengal, which is the northernmost point of the Ganga Delta. Here, the river bifurcates, splits.
Splits? Into what?
The main branch flows southwards into Bangladesh, where it's known as the Padma, and is joined by the Brahmaputra, known as Jamuna in Bangladesh. Together, they form the Meghna, which flows into the Bay of Bengal. The other branch, the Bhagirathi Hooghly, flows south through West Bengal, past Kolkata, and also into the bay. This whole area forms the massive Ganga-Brahmaputra Delta, also known as the Sundarban Delta.
The Sundarbans,
Famous for its mangrove forests and the Royal Bengal tiger. It's the world's largest and fastest-growing delta. The Ganga itself is over 2,500 kilometers long.
And the sources mention something about its slope causing meanders.
Yes, the drop in elevation from where it enters the plains near Ambala all the way to the Sundarbans is very gradual, only about 300 meters over nearly 1,800 kilometers. That's a slope of roughly 1 meter drop for every 6 kilometers. This very gentle slope causes the river to develop large loops or meanders in the plains.
Wow, that's flat. Okay, what about the third big Himalayan river, the Brahmaputra?
The Brahmaputra also rises in Tibet, very close to the sources of the Indus and the Satluj, east of Mansarovar Lake. It's actually slightly longer than the Indus, but most of its course lies outside India.
It flows east first, right?
Yes, it flows eastwards, parallel to the Himalayas in Tibet, where it's known as the Sangpo. It carries less water and silt there because it's a cold, dry area.
Sangpo. Then it enters India.
It takes a dramatic U-turn around Amcha Barwa, a massive peak, and enters India in Arunachal Pradesh through a deep gorge. Here it's called the Dihang.
Hang first, then Brahmaputra.
Right. It's joined by other tributaries like the Dibang, the Lohit, and several others, and then it's known as the Brahmaputra as it flows through Assam.
And it changes character once it's in India.
Completely. Yeah. Because it enters a region of high rainfall, the river carries a huge volume of water and also a considerable amount of silt picked up in India.
And that causes problems you mentioned earlier.
It does. The Brahmaputra forms what's called a braided channel. It splits into numerous channels with many riverine islands between them. Majuli, the world's largest inhabited riverine island, is in the Brahmaputra.
Well, little island. Okay.
But because it carries so much silt, the silt gets deposited on the riverbed, raising it. This causes the river to frequently overflow its banks during the monsoon, leading to widespread and devastating floods in Assam and neighboring Bangladesh. The river also tends to shift its channel frequently because of these silt deposits.
A powerful and sometimes destructive river. Okay, shifting south now to the peninsular river systems. You said the Western Ghats are the main water divide.
Yes, they form the main divide, running north-south close to the western coast.
And most major rivers flow east from there into the Bay of Bengal.
Correct. The major peninsular rivers flowing east include the Mahanadi, the Godavari, the Krishna, and the Kaveri. All these rivers make deltas at their mouth.
And you stand out among them.
The Godavari is the largest peninsular river, about 1,500 kilometers long. Its drainage basin is huge, covering parts of Maharashtra, Madhya Pradesh, Odisha, and Andhra Pradesh. Because of its size and extent, it's often referred to as the Dakshin Ganga, or Ganga of the south.
Dakshin Ganga. Interesting. What about the others?
The Krishna is the next largest, around 1,400 kilometers long. The Kaveri rises in the Brahmagiri range of the Western Ghats. It's notable for forming the second biggest waterfall in India. the Shibasamudram Falls, which has been used for generating hydroelectric power for a long time.
Shivasamudram Falls.
Okay.
Okay. Now, those west-flowing exceptions, the Narmada and Tapi.
Right. These are the main west-flowing rivers. They are unique because they flow through rift valleys.
Rift valleys, what does that mean?
A rift valley is a long, narrow valley formed by the sinking of a block of land between two faults or cracks in the Earth's crust. So, the Narmada and Tapi flow westwards in these trough-like valleys.
Where do they rise?
The Narmada rises in the Amarkantak Hills in Madhya Pradesh and flows west towards the Arabian Sea, creating some picturesque locations like the Marble Rocks near Jabalpur and the Dudhar Falls. The Tapi rises in the Satpura Ranges, also in Madhya Pradesh, and flows in a rift valley parallel to the Narmada, but it's much shorter in length.
And they form estuaries, not deltas.
Correct. Besides these two, there are numerous small coastal rivers west of the Western Ghats, like the Sabarmati and Mahi in Gujarat, and the Pharathapuzha and Periyar in Kerala, but they are very short.
Okay, that covers the main river systems. Beyond rivers, the sources talk about lakes. India seems to have many different kinds.
It does. Lakes differ in size and characteristics, and they form in various ways. Some are formed by the action of glaciers and ice sheets, others by wind, river action like oxbow lakes formed when a river meander gets cut off, or by spits and bars forming lagoons in coastal areas.
And human activity.
Yes, dams built across rivers for hydropower generation also create large artificial lakes or reservoirs.
Can you give some examples?
Sure. Ullar Lake in Jammu and Kashmir is mentioned as the largest natural freshwater lake in India, believed to have been formed by tectonic activity. Other freshwater lakes include Dal Lake, Pimtal, Nainital, Loktak, and Barapani.
And saltwater ones.
Coastal lagoons like Chilika Lake, Pulakat Lake, and Kolaru Lake are saltwater. Samphar Lake in Rajasthan is an interesting inland saltwater lake. Its water used for producing salt, and it's seasonal. And an example of a large artificial lake is the Guru Gobind Saga, formed by the Bakra Nangal Project Dam.
Why do lakes matter? What role do they play?
They're quite important. Lakes help regulate the flow of rivers. They store water during heavy rains, preventing floods, and release water during dry seasons, maintaining flow. They can be used to generate hydroelectric power. They also moderate the climate of the surrounding areas, maintain aquatic ecosystems, enhance natural beauty, and are great spots for tourism and recreation.
So, quite valuable. Zooming out again, what's the overall role of these rivers and lakes in India's economy and life?
Rivers are of fundamental importance, as the sources stress. They have been throughout history. River banks attracted settlers from ancient times. Many settlements became cities. They provide the basic natural resource water, which is essential for almost all human activities.
Especially agriculture.
Especially agriculture, which is still the backbone of the Indian economy for a large part of the population. Rivers are vital for irrigation, as well as for navigation and generating hydropower. They are absolutely crucial.
But that vital resource is under serious threat, isn't it? The sources talk about pollution.
Absolutely. River pollution is a massive issue. The growing demand for water for domestic use, municipal supplies, industry, agriculture reduces the volume of water in rivers. At the same time, more and more untreated sewage and industrial effluents are being discharged directly into the rivers.
So less water, more pollution.
Exactly. The pollution load often exceeds the river's natural self-cleansing capacity. Urbanization and industrialization are major contributors to this problem, significantly degrading the quality of river water across the country.
Are there efforts being made to address this?
Yes. The sources mention government initiatives like the Ganga Action Plan, started back in 1985, and the broader National River Conservation Plan, NRCP, launched in 1995. These aim to improve the water quality of major rivers by tackling pollution sources. It's a huge ongoing challenge.
A critical challenge. Okay, we've explored the land and its water. Now let's look upwards at the rhythms set by the atmosphere India's climate, famously dominated by the monsoon.
Right. The climate is another defining feature of India. And just to be clear, climate refers to the sum total of weather conditions and variations over a large area for a long period of time, typically more than 30 years. Weather is the state of the atmosphere over an area at any specific point in time.
Climate is long-term average. Weather is short-term state.
Got it.
And India's climate type is?
It's described as the monsoon type. The word monsoon comes from the Arabic word masim, which literally means season.
And it refers to that seasonal wind shift.
Exactly. It refers to the distinct seasonal reversal in the wind direction during the year. This is the dominant characteristic of the climate in India and much of South and Southeast Asia.
But even within that overall monsoon pattern, the sources, there's huge variation across the country.
Massive variation. It's really important to grasp this. While the monsoon pattern provides a broad framework, the actual climatic conditions vary significantly from place to place and season to season.
Can you give some examples of that variation?
Sure. Take temperature. In summer, the mercury can occasionally touch 50 degrees C in parts of the Rajasthan desert, whereas it might be around 20 degrees C in Pahalgam in Jammu and Kashmir on the same day. In winter, the temperature in Dras near Kargil can plummet to as low as minus 45 degrees C, while Thiruvananthapuram in the south might have a pleasant 22 degrees C.
Huge temperature swings depending on location and season. What about rainfall?
Similar extremes. Annual precipitation varies from over 400 centimeters in Meghalaya in the northeast. Mawsynram gets the world's highest average rainfall down to less than 10 centimeters in Ladakh and parts of western Rajasthan. Most of the country receives rainfall from the southwest monsoon between June and September, but some areas like the Tamil Nadu coast get a large portion of their rain during October and November from the retreating monsoon.
So timing and amount vary hugely.
Yes, and these variations in temperature, rainfall, and seasonality have a profound impact on people's lives. The types of clothes they wear, the houses they live in, the food they eat, the crops they grow. Everything is shaped by the local climate.
What are the key factors that control or affect India's specific climate? Why is it the way it is?
The sources list several key controls. First is latitude. The Tropic of Cancer passes through the middle, so the southern half is in the tropics, closer to the equator, and the northern half is in the subtropics.
Okay, latitude. What else?
Altitude is crucial. The Himalayas to the north act as a massive barrier, preventing the cold winds from Central Asia from entering the subcontinent. This is why India has relatively milder winters compared to other areas at similar latitudes. The mountains also trap the monsoon winds, forcing them to shed their moisture within the subcontinent.
So the mountains are like a climate shield and rain catcher.
In a way, yes. Then there's the pressure and wind system. This is key to the monsoon mechanism itself. Factors like surface pressure and winds, upper air circulation, and western cyclonic disturbances all play a role in the seasonal reversal of winds.
Distance from the sea is another factor.
Yes, what's called continentality. Coastal areas experience less contrast in temperature conditions because of the moderating influence of the sea. As you move further inland, the sea's influence diminishes and seasonal temperature contrasts become much more extreme.
Makes sense. Any others?
Ocean currents also influence the climate, especially of coastal areas. And finally, relief features the mountains, plateaus, plains play a major role in influencing local temperature, air pressure, wind direction, and the amount and distribution of rainfall. For example, the windward slopes of the Western Ghats get heavy rain, while the leeward side gets much less.
So a complex interplay of factors. Let's walk through the main seasons as described in the sources, starting with the coolest time of year.
Okay, the cold weather season, or winter. This generally lasts from mid-November to February in northern India. December and January are typically the coldest months.
What are conditions like then?
Temperatures generally decrease as you go from south to north. The average temperature in Chennai might be 24-25 degrees C, while in the northern plains it could range from 10-15 degrees C. Days are warm, nights are cold, frost is common in the north, and heavy snowfall occurs in the higher reaches of the Himalayas.
What are the winds doing during winter?
The prevailing winds are the northeast trade winds. They blow from land to sea over most of the country, so it's generally a dry season. However, these winds pick up some moisture when they blow over the Bay of Bengal and cause some winter rainfall along the Tamil Nadu coast.
So some rain in the southeast.
Yes. Another important feature of the winter season in the north is the inflow of shallow cyclonic disturbances originating over the Mediterranean Sea. These are called western cyclonic disturbances.
Western disturbances, what do?
They cause much-needed winter rains over the northern plains and snowfall in the mountains. Although the amount of rain is small, it's locally known as Mahawat, and is incredibly important for the cultivation of rabi crops, like wheat.
Mahawat for rabi crops. Okay, how about the south in winter?
The peninsular region doesn't have a very well-defined cold season. Due to the moderating influence of the sea, there's hardly any noticeable change in temperature pattern during winter.
Right, milder down south. Okay, next up, things start to heat up.
Yes, the hot weather season, or summer. This is roughly from March to May. As the sun moves northwards, the global heat belt shifts north too. Temperatures start rising across the country.
How hot does it get?
In March, the highest temperatures are around 38 degrees C in the Deccan Plateau. By April, temperatures in Gujarat and Madhya Pradesh reach 42 to 43 degrees C. In May, temperatures of 45 degrees C are common in the northwestern parts of the country. Peninsular India stays slightly cooler due to the ocean's influence.
And this heat creates low pressure.
Exactly. A low-pressure area develops over the northwestern plains. Towards the end of May, this trough extends from the Thar Desert towards the Chotnapur Plateau. Air circulation starts setting in around this trough.
Any specific weather features associated with summer?
Oh yes. A striking feature is the Lu. These are strong, gusty, hot, dry winds that blow during the day over north and northwestern India. They can be very intense and sometimes even fatal if you get direct exposure.
The Lu sounds nasty. Anything else?
Dust storms are very common during May in northern India. They bring temporary relief as they might lower the temperature slightly and sometimes bring light rain and cool breeze. This is also the season for localized thunderstorms, often accompanied by violent winds, torrential downpours, and even hail.
Thunderstorms. Do they have local names?
Yes. In West Bengal, these storms are known as Kala Baisakhi, meaning calamity for the month of Baisak. Towards the close of the summer season, you also get pre-monsoon showers, especially in Kerala and Karnataka. These are often called mango showers, as they help in the early ripening of mangoes.
Mango showers. Nice name. Okay, then goes the big event. The advancing monsoon, the main rainy season.
Yes, this typically starts by early June. The low-pressure condition over the northern plains intensifies significantly by this time. It attracts the trade winds of the southern hemisphere.
Winds from the southern hemisphere. How does that work?
These southeast trade winds originate over the warm subtropical areas of the southern Indian Ocean. They cross the equator and, due to the Coriolis force, they get deflected to the right and blow towards the low-pressure area over the Indian subcontinent as the southwest monsoon wanes.
Ah, they cross the equator in turn, and they bring rain.
Oh, yes. These winds blow over the warm ocean, gathering abundant moisture. They approach the landmass with strong velocities, averaging 30 kilometers per hour. Except for the extreme northwest, the monsoon winds cover the country in about a month. Their arrival brings about a total change in the weather.
Heavy rain begins.
Yes, the onset is often marked by a sudden burst of rainfall continuing for several days. The windward side of the Western Ghats receives very heavy rainfall, more than 250 centimeters. The northeastern parts of the country also receive massive amounts. Masinram in the southern ranges of the Khasi Hills gets the highest average rainfall in the world.
Masinram, okay. Does rainfall decrease as you go inland?
Yeah. Generally, yes. Rainfall decreases as you go east to west across the northern plains. Rajasthan and parts of Gujarat get very scanty rainfall.
The monsoon isn't just continuous rain for months, though, is it? The sources mention breaks.
That's a very important characteristic. Monsoon rainfall happens only for a few days at a time. It's interspersed with rainless intervals. These breaks in the monsoon are related to the movement of the monsoon trough.
The monsoon trough.
Yes, this low-pressure trough is a key feature. Its axis runs roughly parallel to the Himalayas. When the axis of the trough lies over the plains, rainfall is good in these parts. However, when the axis shifts closer to the Himalayas, there are longer dry spells over the plains, while widespread rain occurs in the mountain catchment areas of the Himalayan rivers.
And that mountain rain can cause?
It can cause devastating floods in the plains downstream. The frequency and intensity of tropical depressions that form over the Bay of Bengal also influence the amount and duration of monsoon rains. These depressions follow the axis of the monsoon trough.
So the monsoon is quite variable.
Extremely. It's known for its uncertainties. The timing of its arrival and withdrawal can vary. The distribution of rain is uneven, and the intensity fluctuates, leading to alternating periods of flood and drought. This variability heavily impacts agriculture and the overall economy. It keeps farmers guessing every year.
A lifeline, but an unpredictable one.
Oh.
Okay, after the main rainy season, there's a transition period.
Yes, the retreating or post-monsoon season, also called the transition season. This happens during October and November. With the apparent movement of the sun towards the south, the monsoon trough or low-pressure trough over the northern plains becomes weaker.
So the southwest monsoon weakens.
Exactly. It's gradually replaced by a high-pressure system. The southwest monsoon winds start withdrawing gradually. By the beginning of October, the monsoon withdraws completely from the northern plains.
What's the weather like during this transition?
October and November form a period of transition from hot rainy season to dry winter conditions. The retreat is marked by clear skies and a rise in temperature. While days are warm, nights become cool and pleasant. However, owing to the conditions of high temperature and humidity, the weather can become rather oppressive during the day. This is commonly known as October heat.
October heat. Sounds uncomfortable.
It can be. In the second half of October, the mercury begins to fall rapidly, especially in northern India.
And this is cyclone season on the East Coast, you mentioned.
Yes. The low-pressure conditions, which were over northwestern India, shift to the center of the Bay of Bengal by early November. This shift is associated with the occurrence of cyclonic depressions, which generally originate over the Andaman Sea.
And they head towards the coast.
Yes. These cyclones often cross the eastern coast of India, causing heavy and widespread rain. They can be very destructive, causing great damage to life and property, particularly in the deltas of the Godavari, Krishna, and Kaveri rivers, and the coasts of Odisha, West Bengal, and Bangladesh.
So, a dangerous time for the East Coast. And some areas get most of their rain now.
Correct. The bulk of the rainfall for the Coromandel Coast, Tamil Nadu coast, is derived from these depressions and cyclones during the retreating monsoon period.
Okay. Looking at the rainfall distribution map overall, you see these huge differences.
Absolutely. Parts of the western coast and northeastern India receive over 400 centimeters of rainfall annually, but it's less than 60 centimeters in western Rajasthan and adjoining parts of Gujarat, Haryana, and Punjab. Rainfall is also low on the interior of the Deccan Plateau, east of the Sahyadris, Western Ghats, that's a rain shadow area, and Leh in Ladakh receives very little precipitation, less than 20 centimeters.
High rainfall areas prone to floods, low rainfall areas prone to drought.
That's generally the pattern. Areas of high rainfall are liable to floods, while areas of low rainfall are drought prone due to the high variability year to year.
The sources end this climate section by calling the monsoon a unifying bond for India. How can something so variable and sometimes destructive be unifying?
It's a fascinating point. Despite the great climatic variations within India, the monsoon provides a certain rhythmic cycle of seasons that the entire country experiences, more or less.
A shared rhythm.
Yes. The Indian landscape, its animal and plant life, the entire agricultural calendar, and the life of the people, including their festivities, revolve around this phenomenon. Year after year, people from north to south, from east to west, eagerly await the arrival of the monsoon.
It connects everyone.
It does. These monsoon winds bind the whole country by providing water to set agricultural activities in motion. The river valleys which carry this water also unite single river valley units. It's a powerful shared experience that cuts across regional differences.
A shared annual drama, as you put it earlier. Okay, from the climate and its cycles, let's dive into the sheer wealth of living things across India, its incredible natural vegetation and wildlife. The sources call it a mega biodiversity country.
That's right. India is recognized globally as one of only 12 mega biodiversity countries. That means it hosts an enormous variety and richness of plant and animal life.
Just how diverse are we talking? What are the numbers?
The numbers are pretty stunning. The sources mention India has about 47,000 different plant species. That puts it 10th in the world and 4th in Asia in terms of plant diversity.
47,000 plant species?
Yes. And about 15,000 of those are flowering plants, which constitutes about 6% of the world's total flowering plants. It also has many non-flowering plants like ferns, algae, and fungi.
And animals.
For animals, the sources estimate approximately 90,000 species, plus a rich variety of fish in its fresh and marine waters, accounting for about 12% of the world's stock, and about 5-8% of the world's amphibians, reptiles, and mammals are found here. It's incredibly rich.
Amazing numbers. The sources define natural vegetation specifically, right? Yeah. To distinguish it from things people plant.
Yes, exactly. Natural vegetation, sometimes called virgin vegetation, refers to a plant community that has grown naturally without human aid and has been left undisturbed by humans for a long time. So, cultivated crops, fruits, orchards, gardens, they form part of vegetation, but not natural vegetation in this ecological sense.
And they distinguish endemic versus exotic species.
Right. Endemic or indigenous species are those purely of Indian origin, while exotic species are those that have come from outside India.
And just to be clear on the terms flora and fauna.
Simple enough. Flora is used to denote plants of a particular region or period, and fauna refers to the species of animals in that region or period.
Okay. The sources break down India's natural vegetation into 5 major types, largely based on climate, particularly rainfall, and relief. What's the first type?
First up are the tropical evergreen forests. As the name suggests, they stay green year-round.
Where do you find these?
You find them in areas with heavy rainfall over 200 centimeters annually, with just a short dry season. Places like the windward slopes of the Western Ghats, the island groups of Lakshadweep and Andaman and Nicobar, upper parts of Assam, and the Tamil Nadu coast.
What are they like? Dense?
Yeah.
Tall?
Very dense and multi-layered. Trees reach great heights, often up to 60 meters or even above. Since there's no definite time for trees to shed their leaves, these forests appear green all year round. Commercially important trees found here include ebony, mahogany, rosewood, rubber, and cinchona.
Animals.
Common animals include elephants, monkeys, lemurs, and deer. The one-horned rhinoceros is found in the evergreen forests of Assam and West Bengal as well.
Okay, evergreen forests. Next are the most widespread forests in India.
Yes, the tropical deciduous forests. These are also often called monsoon forests. They are found in regions receiving rainfall between 200 centimeters and 70 centimeters.
Deciduous means they shed leaves.
Correct. The key characteristic is that trees of this forest type shed their leaves for about 6 to 8 weeks during the dry summer season. This helps conserve water.
And they vary depending on how much rain they get within that range.
Exactly. Based on water availability, these forests are further divided into moist deciduous and dry deciduous.
Okay, what's the difference?
Moist deciduous forests are found in areas with rainfall between 100 and 200 centimeters. They exist mostly in the eastern parts of the country, northeastern states, along the Himalayan foothills, Jharkhand, West Odisha, Chhattisgarh, and on the eastern slopes of the Western Ghats. Teak is the most dominant species here. Others include bamboos, sal, shisham, sandalwood, care, kusum, arjun, mulberry.
Teak and sal, common names. And dry deciduous.
Dry deciduous forests are found in areas with rainfall between 70 centimeters and 100 centimeters. These cover rainier parts of the peninsular plateau and the plains of Bihar and Uttar Pradesh. They tend to be more open stretches where trees like teak, sal, peepal, and neem grow. Large parts of this region have been cleared for cultivation or are used for grazing.
And animals in deciduous forests.
Common animals found in both types include the lion, tiger, pig, deer, and elephant. You also find a huge variety of birds, lizards, snakes, and tortoises.
Lions and tigers here. Okay, shifting now to the really dry areas. What kind of vegetation survives there?
That would be the tropical thorn forests and scrubs. These are found in regions with less than 70 centimeters of rainfall. Typically in the northwestern parts of the country, including semi-arid areas of Gujarat, Rajasthan, Madhya Pradesh, Chhattisgarh, Uttar Pradesh, and Haryana.
Thorny makes sense for dry areas.
Yes, the vegetation consists mainly of thorny trees and bushes. Plants are scattered and have features to conserve water, long roots penetrating deep into the soil to get moisture, stems that are succulent to store water, and leaves that are often small or modified into thorns to reduce water loss through transpiration. Common plants include acacias, palms, euphorbias, and cacti.
What kind of animals manage to live there?
Animals adapted to arid conditions. Common ones are rats, mice, rabbits, fox, wolf, tiger, lion. Ingur forest, which has dry deciduous and thorn elements. Wild ass, horses, and camels.
Wild ass and camels, right? Okay, now heading up into the mountains. How does vegetation change with altitude?
This is called montane forests. In mountainous areas, the decrease in temperature with increasing altitude leads to corresponding changes in natural vegetation. It's almost like seeing the vegetation change from tropical to tundra as you climb higher.
Like different climate zones stacked vertically.
Exactly. Between 1,000 and 2,000 meters, you find wet, temperate-type forests with evergreen, broadleaf trees like oaks and chestnuts dominating.
Oaks and chestnuts.
And higher up, between 1,500 and 3,000 meters, temperate forests containing coniferous trees like pine, deodar, silver fir, spruce, and cedar are found. These cover mostly the southern slopes of the Himalayas and high-altitude areas in southern and northeast India.
Conifers like pine and fir, what about even higher?
At higher elevations, generally above 3,600 meters, temperate forests and grasslands give way to the alpine vegetation. Common trees are silver fir, junipers, pines, and birches. As you approach the snow line, these trees become progressively stunted.
Stunted trees then what?
Ultimately, they merge into alpine grasslands. These grasslands are used extensively by nomadic tribes like the Gujars and Bakarwals for grazing their livestock during summer. At even higher altitudes above the grasslands, you get mosses and lichens, characteristic of tundra vegetation.
From oaks to mosses. And the animals change with altitude too.
Yes. Animals found in these montane areas include the Kashmir stag, spotted deer, wild sheep, jackrabbit, Tibetan antelope, yak, snow leopards, squirrels, shaggy horned wild ibex, bear, and the rare red panda. Sheep and goats with thick hair are also common.
Snow leopard and yak, iconic mountain animals. Okay, the fifth and final vegetation type is unique to the coasts, particularly deltas.
Right, the mangrove forests. These are also called tidal forests because they are found in coastal areas influenced by tides. Mud and silt get accumulated on such coasts.
And the plants are adapted to salty water and mud.
Yes, dense mangroves are common varieties with roots of the plants submerged underwater. They thrive in the deltas of major rivers like the Ganga, Mahanadi, Krishna, Godavari, and Kaveri.
The Ganga-Brahmaputra Delta has famous mangroves.
Yes, the Sundarbans Delta. It gets its name from the Sundari tree, which provides durable hard timber. Palm, coconut, kiora, agar also grow in some parts of the delta.
And famously home to a specific animal, as we mentioned earlier.
The Royal Bengal tiger is the most famous animal here. Turtles, crocodiles, gharials, a type of fish-eating crocodile, and various snakes are also found in these forests and waters.
Okay, that covers the main vegetation types. Looking at the wildlife overall across all these habitats, any particularly interesting facts highlighted in the sources?
Well, India has a rich heritage of fauna, as the numbers suggest. Elephants are found in the hot, wet forests of Assam, Karnataka, and Kerala. One-horned rhinoceroses live in swampy and marshy lands of Assam and West Bengal. Arid areas like the Rann of Kutch are the habitat for the wild ass, while the Thar Desert is home to camels.
Specific habitats for specific large animals.
Yes. You also find Indian bison, gar, nilgai, blue bull, chusinga, four-horned antelope, gazelle, and various species of deer. India also has several species of monkeys.
And here's a cool fact the sources mention about big cats.
Ah, yes. India is the only country in the world that is home to both tigers and lions in the wild.
Both? Where are they found?
The natural habitat of the Indian lion, the Asiatic lion, is now restricted to the Gir forest in Gujarat. Tigers, on the other hand, are found in the forests of Madhya Pradesh, the Sundarbans of West Bengal, and the Himalayan region, among other places. Leopards are also members of the cat family found across India.
Amazing to have both. Why is all this biodiversity, the plants and animals, so incredibly important? Why should we care?
The sources stress that this biodiversity is fundamentally important for human survival and well-being. Ecosystems provide essential services. Plants provide us timber, firewood, fodder, medicinal products, latex, resins, etc. Wildlife includes animals, birds, insects, aquatic life. They provide milk, meat, hides, wool. Insects help in pollination of crops and fruit trees. Fish provide nutritious food.
So direct resources and ecosystem functions.
Exactly. Every species has a role to play in the ecosystem, hence conservation is essential. We depend on this intricate web of life.
But this crucial biodiversity is under threat, isn't it?
Tragically, yes. The sources are clear on this. Excessive exploitation of plant and animal resources by human beings has disturbed the ecosystems significantly.
How so? What are the main threats?
Major causes include hunting by greedy hunters for commercial purposes, pollution due to chemical and industrial waste and acid deposits, the introduction of alien or non-native species, and perhaps the biggest driver, reckless cutting of forests for cultivation, habitation, infrastructure development. Deforestation is a huge problem.
And the result?
The result is that many species are endangered and some have already become extinct. The sources mention around 1,300 plant species are endangered and 20 species are extinct. Quite a few animal species are also endangered and some have vanished. It's a serious situation.
So what's being done to protect this rich heritage? What conservation efforts are mentioned?
The government has taken several steps. 18 biosphere reserves have been set up in the country to protect flora and fauna. 12 of these, including the Sundarbans, Nanda Devi, Gulf of Mannar, Nilgiris, and others, have been included in the World Network of Biosphere Reserves.
Biosphere reserves. What else?
Financial and technical assistance is provided to many botanical gardens. Specific conservation projects for endangered species have been introduced, such as Project Tiger, Project Rhino, Project Great Indian Bustard, and others. And there's a network of 103 national parks, 563 wildlife sanctuaries, and numerous zoological gardens established across the country.
A network of protected areas.
Yes. The goal is to take care of the country's natural heritage and preserve biodiversity for future generations. Everyone needs to realize the importance of the natural ecosystem for our own survival.
The sources also specifically mention India's long history and knowledge of medicinal plants.
It's a very rich tradition. India has been known for its herbs and spices from ancient times. Ayurveda, the traditional Indian system of medicine, mentions around 2,000 plants, and at least 500 are in regular use. The World Conservation Union's Red List has identified many threatened medicinal plants.
Can you give a few examples mentioned?
Sure, sarpaganda, found only in India, is used to treat blood pressure. Geeman juice helps control diabetes. Arjun bark is used for earache and regulating blood pressure. Baboo leaves help with eye sores. Neem has great antibiotic properties. Tulsi plant is used for cough and cold. Kachnar helps with asthma and ulcers. These are just a few common examples.
A living pharmacy, but also under threat. It really paints a picture of incredible natural wealth that requires urgent and ongoing protection.
Absolutely. From the spectacular sight of migratory birds like Siberian cranes visiting wetlands in winter to flamingos nesting in the Rann of Kutch, India's living tapestry is vibrant but incredibly fragile. We must stop the indiscriminate destruction.
A powerful note to end that section on. Okay, we've journeyed through the land, the water, the climate, and the rich tapestry of life. Now let's turn to the final crucial element. The people who inhabit this diverse landscape, the population story of India.
Yes, understanding the population is absolutely key to understanding India itself. As the sources point out, people are pivotal. They are the producers and consumers of the Earth's resources.
They shape the world around them.
Exactly. It's humans who utilize resources and create the social and cultural environment. Natural events like floods or earthquakes only become disasters when they affect populated areas. So, population numbers, where people live, distribution, how the population is growing or changing, and its characteristics like age structure, sex ratio, literacy, provide the essential background for understanding and appreciating all other aspects of the environment.
And the main source for this kind of detailed information?
It's the Census of India. Census is an official count of the population done periodically. In India, the first census was held in 1872, but the first complete one was in 1881. Since then, censuses have been held regularly every 10th year. It provides a wealth of information.
Okay, looking at the most recent data mentioned in our sources, which seems to be primarily the 2011 census, what's the picture of India's population size and how it's spread out?
Right. Based on the March 2011 data, India's population stood at 1,210.6 million people.
Over 1.2 billion. That's a staggering number.
It really is. Think about this. That accounted for 17.5% of the entire world's population at the time. And this massive population lives on just 2.4% of the world's total land area.
Wow. 17.5% of people on 2.4% of land. That immediately tells you density is high. And is it spread evenly?
Not at all. The distribution is highly uneven. Some states are incredibly populous. Uttar Pradesh, for example, had the highest population with almost 199 million people. That alone was about 16% of India's total population.
One state holding 16% of the people. Any examples of less populated areas?
Sure. Contrast UP with a Himalayan state like Sikkim, which had a population of just 0.6 million, or the island territory of Lakshadweep with only about 64,000 people. Huge differences.
So it's really concentrated.
Very much so. The sources note that almost half of India's entire population lives in just 5 states: Uttar Pradesh, Maharashtra, Bihar, West Bengal, and Andhra Pradesh, as it was constituted in 2011.
Half the people in just 5 states. And interestingly, the largest state by area.
Right. Rajasthan, which is the largest state in terms of land area, had only 5.5% of the total population. So size of state doesn't directly correlate with population size.
Clearly not. This uneven distribution must mean population density varies wildly, too.
It absolutely does. Population density is calculated as the number of persons per unit area, usually per square kilometer. India is one of the most densely populated countries in the world. The average density in 2011 was 382 persons per square kilometer.
382 average, but huge variations within that.
Huge. Densities vary from as high as 1,102 persons per square kilometers in Bihar down to only 17 persons per square kilometers in Arunachal Pradesh. That gives you a sense of the extreme range.
Bihar over 1,100, Arunachal just 17. And that density, it connects directly back to the physical features and climate we discussed earlier.
Absolutely. There's a strong correlation. You generally find sparse populations in areas with rugged terrain, unfavorable climatic conditions like mountainous states, desert regions. States with density below 250 persons per square kilometer often fall into this category.
Okay, low density and tough environments, moderate density.
Moderate population densities are often found in areas with hilly, dissected, or rocky terrain, moderate to low rainfall, and less fertile soils. States like Assam and most of the peninsular states tend to have moderate densities.
And the highest densities.
High to very high population densities are characteristic of those flat northern plains we talked about, with their fertile soils and abundant rainfall, and also coastal states like Kerala in the south. Basically, where agriculture is productive and life is relatively easier, densities tend to be much higher.
Makes perfect sense. Population isn't just a static number, though. The sources emphasize it's always changing.
Right. It's a dynamic phenomenon. The numbers, distribution, and even the composition, like age structure of the population, are constantly changing. This change is influenced by the interplay of three main processes: births, deaths, and migration.
Okay, let's look at population growth first. How is that defined?
Population growth refers to the change in the number of inhabitants of a country or territory during a specific period of time, say over the last 10 years. This change can be expressed in two ways: in terms of absolute numbers added each year or decade, or in terms of percentage change per year, the annual growth rate.
Absolute numbers versus percentage rate. How has India's population been growing according to the sources?
It's seen massive growth over the decades. From 361 million in 1951, it increased steadily to reach 1,210 million by 2011. For a significant period, particularly from 1951 to 1981, the annual rate of population growth was actually increasing, leading to a rapid population explosion.
The growth rate was accelerating.
Yes. However, since 1981, the sources note that the rate of growth started declining gradually. This was primarily because birth rates started to fall significantly during this period.
Okay, so the rate of growth has slowed down since the 80s. But here's that key aha moment from the material again. Even with the rate declining, what about the number of people added?
That's the crucial point. Despite the declining growth rate, the sheer number of people added each decade was still increasing for a long time, only showing a slight dip in the last decade covered, 2001-2011. Why? Because even a lower growth rate applied to a very large population base, over 1 billion people, still yields a huge absolute increase each year.
So a smaller percentage of a much bigger number is still a big number.
Precisely. The sources highlight that India added a massive 182 million people in the 1990s alone. This large annual addition to the population makes it harder to conserve resources, protect the environment, and improve living standards for everyone. It neutralizes many efforts.
A major challenge. And the projection mentioned in the sources is that India might soon become the most populous country.
Yes, based on the trends at the time the sources were compiled, there were projections suggesting India could potentially overtake China to become the most populous country in the world around the year 2045.
Yeah.
Note, more recent data suggests this may have already happened or is imminent.
Okay. Let's quickly break down those three processes driving population change: births, deaths, and migration.
Sure. Birth rate is the number of live births per 1,000 persons in a year. It's a major component of growth, and in India, birth rates have historically been higher than death rates, leading to population increase.
And death rate.
Death rate is the number of deaths per 1,000 persons in a year. The rapid decline in death rates over the past century due to better public health, nutrition, sanitation, medical advances was the main cause of the high rate of population growth experienced earlier.
So deaths dropped, births stayed high for a while, causing growth.
Exactly. Since 1981, as birth rates also started declining significantly, the gap between births and deaths narrowed, leading to that gradual decline in the overall rate of population growth we mentioned.
Okay. And the third factor, migration.
Migration is the movement of people across regions and territories. It can be internal within the country or international between countries.
How does migration affect population size?
International migration obviously changes the size of the population. Emigration decreases immigration, increases it. But internal migration, people moving within India, doesn't change the total size of the country's population, but it significantly influences the distribution of population within the country.
It changes where people live.
Yes, and it also changes the demographic composition of both the areas people leave, areas of out-migration, and the areas they move to, areas of in-migration, affecting things like age structure and sex ratios in those specific locations.
What's the main pattern of internal migration in India, according to the sources?
The most significant trend has been migration from rural areas to urban areas.
Rural to urban. Why does that happen?
It's driven by both push factors in rural areas, things like poverty, lack of employment opportunities, pressure on land, and pull factors in cities, the perceived attraction of better employment prospects, higher wages, better services, and amenities.
Push from rural, pull to urban. And the effect?
This persistent rural to urban migration has led to a steady increase in the percentage of the population living in urban areas. It went from about 17.3% in 1951 up to 31.8% in 2011. It also contributed to the rapid growth in the number of large cities, particularly the million-plus cities, which grew significantly between the 2001 and 2011 censuses.
Okay. The sources also specifically highlight the adolescent population as a key feature.
Yes, adolescents, generally grouped as 10 to 19 years of age, constitute a significant portion of India's population, about 1/5 according to the data used. This group is incredibly important as they are the future resource for the country.
But they also have specific needs.
They do. They have higher nutritional requirements than younger children or adults. Unfortunately, the sources point out that poor nutrition is common among adolescents in India. Many girls suffer from anemia. These problems need focused attention, and increasing awareness and education, especially for adolescent girls, is crucial.
A vital group needing support. Finally, the sources mention the National Population Policy.
Right. Recognizing the link between population growth and development, the government of India initiated a comprehensive family planning program way back in 1952. Over the years, policies evolved. The National Population Policy, NPP 2000, is mentioned as a key recent framework.
What were some of its goals?
NPP 2000 aimed for several things, including providing free and compulsory school education up to age 14, reducing infant mortality rate to below 30 per 1,000 live births, achieving universal immunization against vaccine-preventable diseases, promoting delayed marriage for girls, and making family welfare a people-centered program, moving beyond just targets.
A multifaceted approach. Okay. Wow. We've really covered a tremendous amount of ground today on the deep dive. Feels like we've built a picture layer by layer.
We really have. We started by placing India in the world, getting a handle on its sheer scale and strategic location.
Then we journeyed through its truly varied physical landscapes, those towering Himalayas, the vast fertile northern plains, the ancient peninsular plateau, the dry desert, the coastal strips, and the island groups out in the ocean.
We followed the water, didn't we? Differentiating the mighty perennial Himalayan rivers from the vital but often seasonal peninsular ones. We saw how they shape the land, form deltas or estuaries, and the role lakes play too.
Then we felt the power of the climate, particularly the monsoon, understanding its seasonal rhythm, the huge variations in temperature and rainfall across the country, and how profoundly it shapes life.
And we explored that incredible tapestry of life, the plants and animals that make India a global biodiversity hotspot. We looked at the different types of forests and vegetation, the unique wildlife found across these diverse habitats.
And importantly, recognized the threats and the critical need to protect this vulnerable natural heritage.
Finally, we brought in the human dimension, the story of India's massive and growing population, its uneven distribution linked so closely to the physical environment, the factors driving population change, like births, deaths, and migration, and some key demographic features.
It's really clear, looking back at all these pieces from the sources together, how interconnected everything is. You can't really understand one aspect without considering the others.
Absolutely. The geography shapes the climate influences the vegetation and the river systems, and all of this fundamentally impacts where and how people live, the resources they depend on, the challenges they face, like floods or droughts, and the opportunities available to them.
Each element builds upon the others, creating that much more complete picture than looking at any single part in isolation.
Exactly.
We hope we've managed to give you, listener, that shortcut we talked about at the beginning, pulling out some of those important and interesting nuggets from these sources to give you a solid, interconnected understanding of this complex and fascinating country.
But of course, as you said at the start, this is just scratching the surface. India's complexity and wonder run incredibly deep. There's always more to learn and connect.
Indeed. As a final thought to leave you with, something to maybe mull over.
Yeah, think about how the very specific geological history and physical features we discussed, like the ancient stability of the Deccan Plateau, compared to the young, still active, unstable Himalayas.
I like that contrast.
How that deep geological reality doesn't just define regions on a map, but has a direct, tangible impact on everything, from traditional farming practices suited to different soils and terrains, to modern building codes needed in earthquake-prone zones, to the very types of natural hazards, erosion, landslides, floods, droughts that people in those specific areas have to contend with in their daily lives. The deep past shapes the present reality.
A powerful connection to consider. Thank you so much for joining us on this deep dive.